All right, I'm here with Team Croatia, and we're going to talk about some very interesting work they've been doing. Please introduce yourselves and tell me a little bit about the project.
Okay, we are a team from Croatia. Our solution is called Smart ECG, and what it does, it records heart work, and we in that way can analyze heart work and raise alarm if some irregularities happen. How we do it, we'll describe you right now. Probably you can hear beeping. It is coming from this little device, this Bluetooth ECG device. It is connected to my body with 4 electrodes. 2 of them are down here, 2 are here. After we apply ECG device on the patient, we send ECG data via Bluetooth connection. You can see it's all wireless, mobile, portable. We send it to a PDA application. On the PDA application, data is represented, and you can see that graph doesn't look so smooth as on our logo. If you take a look at our logo, you will see that green line. It is a so-called QRS segment. It represents 1 heartbeat. You can see on our screen that it is not so smooth. Why it is not so smooth? Because of the different wireless transmissions in the room, different wireless computer and so on. That's why we need to do filtering, and more about filtering of the data and analyzing, my colleague will tell you a little bit in detail.
Okay, excellent. So who are you?
My name is Zlatko Stapic, and my job was to implement the filtering and data analyzing on our QRS segments and our signal. After the signal is transmitted from our Bluetooth device, this PDA device as a second part of our system actually receives that signal, and the signal is represented on this live graph. But after that, we have to filter the signal and analyze the signal. Over here, you can see the analyzed signal, and there are marks which shows us every heartbeat of a person. And if you can see here, our person is healthy, and his average heart rate is actually 100, about 100, because he's pretty excited now. But his actual heart rate is right now about 90. If the PDA application recognize some problems in a heart work, actually it stores a part of a signal which is critical, and then sends that signal via our GPRS connection to our third and fourth part of our system, which is actually a web service and our SQL Server 2005 driven database.
See that in detail how it works on the architecture slide.
Yes, our architecture slide actually represents our project in global. Here is our patient. Here we have our PDA, our Pocket PC, and our PDA application. Signal is filtered, analyzed, and sent from here to our web service and our database. This connection could be wireless or wired connection. It's important. Here we use GPRS connection to send the critical data to our server. After the critical data actually is transmitted to our server, our doctor, whose patient is, receives an alarming message, and on his mobile phone, then he can see the patient number. I will show you a message soon. He can see the patient ID and detected problem. Here you can see one of our messages. Here it says that this is the patient number 30. A detected problem was tachycardia on that time, and also we send patient's GPS position.
Excellent.
And here you can see our doctor's web application. After the doctor receives his alarm, he sits on his computer in his office, and the critical signal is already there on our web server, so he can see the signal and reanalyze it as himself, by himself. Also, this application helps the doctor to see R-to-R interval heart rate. Actually, this is important because the heart rate isn't the same in every part of a signal, and something like that. Doctor after that, doctor can make a better decision on the patient's condition. And the final, actually not final, part I would like my colleague to tell you more about our community and something we developed for sharing knowledge between doctors.
Okay, so we come to our community. That is, if the doctor selects, for example, he can find the interesting part of the signal in critical segment that was sent via GPRS, and he can click upload to community button, and then he will get the screen on which he can see a preview and put his subject and description on the topic. And here we already have opened our community site, so you can see that here we have a lot of topics for our community. So if we go, if we select one topic, we can see the description, and other doctors can put their comments and so on.
So it enables collaboration.
Yes, collaboration, sharing knowledge, and getting extra another opinion or something like that. And finally, we can show.
Maybe we just have to notice that we didn't use our upload button or something like that because here in the room is a very slow wireless connection and it's lots of problems with the internet. So we showed you opened documents, but this is actually something what really works, and we tried and tested in our Varaždin's hospital. We have our domain expert, Dr. Siniša Car, who helped us, who tested this software, and Varaždin's hospital from Croatia is showing more interest about our project because they are going to implement it on real patients. And of course, we have to show you our last part of our system. It's our GPS monitoring and our
GPS integrated support.
Yes, GPS integrated support. Our patient now is shown here. Problem is tachycardia. Longitude is shown here, and the patient is marked on the map. We see that we are near the Agra, in area where actually we are right now. His name is Marko Velic, and so on. This is also the part of ambulance and a doctor application.
Yes, ambulance integration is a little bit harder here in India because of the level of details for this part of world in the Windows Live Local. Yeah. So we have already one patient who is in New York. You can see ambulance vehicle position, patient position, and in that way we can get direction for maneuvering through the streets and get to the patient really fast and find him on time and so on. In the same way we send the GPS position of the patient, my colleague can show you the tab in the PDA screen with GPS position.
Yes,
in the same way we can send, for example, periodically, for example, every 15 seconds or 30 seconds position of an ambulance, and in that way we can track vehicles down the streets and so on.
Yes, here we can see our current positions, and the system is actually working on in some way we called it remembering a last good position. So if patient enters a subway or some part of a city where there is no GPS signal or garage or something like that, and if something happens to him down there, then the last good position will be sent to ambulance, and it will help them to find him. I think it's all.
So let me ask you though, I mean, why did you choose this specific project? Like, what was it that led you to this specific idea?
Well, because of the main motivation from which derived the idea for this project is that heart diseases are killer number one in today's modern society. We come from Croatia, and in Croatia 52% of all deaths is connected in some way to cardiovascular problems. 17 million people die every year from cardiovascular diseases. In USA, Western Europe, and all developed countries, they are killer number one because of modern lifestyle, junk food, stress, fast living, insufficient activity, and so on, overweight problems, and all that contributes that heart attacks and other heart diseases are killer number one in today's world. So that is the main idea which we tried to help to contribute to solving that huge problem.
So that if somebody does have a heart attack, they can get to the hospital quickly using the system.
Hospital can find him via GPS integrated support and so on. For example, we can also use our system in isolated places, in some catastrophes, natural disasters, fires, earthquakes, when existing medical infrastructure is destroyed, or ambulance can come in the helicopter. You saw it is all small. This can be implemented on smartphone, and this ECG device is also very small. It is very lightweight and portable. So that is one contribute of our system.
Well, great job. Nice work.
We'll just continue to monitoring our patients, and we'll let you go on and discover more great projects.
Great. Thank you so much. Take care. Good luck.
Thank you.
All right, we're with Team Egypt. So, how are you doing? Who are you? What are you working on?
I'm Khaled from Team Egypt. That's my team. We have done Body Watcher.
So this is Buddy Watcher?
Yeah.
So what is it? What's going on here?
When we thought of Body Watcher, we thought about a vision that can fix each and every person's unhealthy choices. You know, every day we make unhealthy choices. We acquire the unhealthy habit throughout our lives because of the fast rhythm. Technology.
Yeah.
It's so fast. So we get so many unhealthy choices that we make every day. It varies from choosing the unhealthy choices of foods that we eat to smoking, excessive drinking, stress and mental management. So we thought of Body Watcher as an application that can be each and every user's special buddy, to be with you in your pocket anywhere, anytime, putting you on the right track, telling you the right choices, the healthy choices, in order to reach this healthy feeling, this healthy state of body, mind, and spirit you acquire from making healthy choices. That's our vision of Body Watcher. Yeah, sure.
Excellent. So,
Yeah.
let's talk a little bit about how's your experience been? Introduce yourself.
This is Nader Badawi, Team Egypt. Farewell. I never thought I would learn so much in this very short period. The experience is undescribable. Actually, what we saw just in India, what we learned, what we managed to control our application, how to construct an application from scratch, that was amazing. Something we never thought we would do.
And the limitations to make it each and every user's personalized body. It's a very simple yet very professional, personalized application. It has no limitations ever on the kind of user using it. If he's a very professional athlete or just an amateur user, if he has special needs, we spend so many time thinking of a way for an application to be each and every user's buddy, regardless of the tastes, aspects, conditions, needs of each user. It absorbs the needs of the user and acquires itself for that user.
Very cool.
Okay.
This guy's, you're like a natural evangelist. You're the team evangelist. Excellent, man. Vic and Dutro would be proud. So, who are you?
I'm Amr Sawi.
Met you yesterday.
Yeah. I'm from Team Egypt, and we are here to present our program Body Watcher. I hope we win.
So let's take a look at your program.
Okay, we have two editions of the program. One is on the PDA, a PDA application, and the other one is a PC application using Windows Presentation Foundation or WPF. This is the PD application.
WPF.
We're using WPF.
Right.
This is the PD application. Amr will explain some of it right now.
Okay, here you can see there are three main sections. Food. Okay. You hold it. the food section, the exercise section, and there's a diet section, diet plan section. In the food section, you can just go and choose meals. You can build your own meal so that Body Watcher can track you. Let's say I will here go to the food search, choose online. What do you want to eat?
Me?
Yeah.
Pasta.
Pasta. Okay. Let's search for pasta. Okay.
It's like, no, don't do it.
Rice white with pasta, dry.
Yeah, garlic, olive oil.
What? This?
Sounds good.
Okay. Click here. You know a detailed info about your food item you've chosen. Here is energy and nutrients.
Okay.
Here you can choose. I'll eat just 1 cup. I don't know why 1 cup. So you can add it to your diary.
That's fine. I usually eat 2 cups of pasta.
Let's say what meal you want.
What, say again?
Choose your meal.
I'll have it for lunch.
Lunch. Okay. Yes.
Yeah.
Click submit. And it's now it's added to your diary. Okay, I'm sorry. I always click the exit button. If you go here, eating diary, choose today.
Okay.
View my history. Oh, it's today. انت is it ايه؟ Oh, yes. Okay. Here in the search again.
That's fine. Maybe the date you chose was different.
Yeah. Say pasta. Oh, I wrote it.
You know, even if you're craving for pasta and your diet plan tells you that you can't eat pasta, you can say just let the diet plan go away. I'll just eat pasta and we'll fix your diet. You know, with Body Watcher you can never spoil your diet. Eat pasta and then do 20 push-ups. You know, for the calories you ate. That's the trend in Body Watcher. It's so flexible and allows you many alternatives. If you have a food item in the plan that you want to change.
Here you will find it. You ate it today at 9:54. 1 cup at meal lunch. You can click details again so you can eat it one more time. And as you can see, its rank is increased because you ate it. So we calculate a rank for you. So
What does the rank mean? What's 1 star?
The rank is the popularity of that specific food item. It's popularity. So if there's 2 kind of ranks, there's the international rank and the personal rank. If you had the international rank is how the world appreciate this kind of food item. If a lot of people in the world eat this food item, it will appear first in your search. When you download this, download this food item into your Pocket PC, now it will be converted to your personal rank. So when you search in your local database, you will find the highest rank food item first.
The favorite to your heart, you know, that the most eaten by you, the most likely food items that you love, you know.
So let me show you the reports. Here. Yes, my status is bad because yeah, what I ate today, pasta only. It's not enough. So you can go to the advanced tracking. Let's say for today, it will tell you your caloric state and here fats, carbohydrates, proteins.
Okay.
It's some major calculations. And here is the diet plan section. You can go Flexi Diet. It's a new feature where you can, let's say I want to be 79 kilograms for this week. Let's say I'm 80 now. Okay.
Hypothetically speaking, yeah.
Here are a set of food items will appear to you where you can customize your diet plan.
Okay.
So you're on a plan, but you can build it by yourself, not stick to some standard plan where you don't like or you have to eat something bad or something. Okay. So if I click here, add to meal. It will calculate to me how many calories, protein, fat, carbohydrates for this meal, and then I can build my own plan. Submit meal, and here's you can lunch, even snacks is. You can eat snacks even in the diet plan, so you don't have to stick to some 3 meals or something.
Sure.
So, and here you can continue with the days, something like this. So, now I will show you the exercise.
Okay.
Here you can search for exercise. If you go to the gym, you want to take some exercise and don't know how to use the machine or something. Even if you're running and you want to tell body watchers that you ran today for about 15 minutes, so it can calculate the calories burned and add it to your diary. So let's say here exercise search online. Let's search. Let's say I'll take the setup application, view exercise. Here's the description of the application with some, it will be useful for your apps, body part used from it. فين البيكتشرز؟ نادر؟ sorry, الابلكيشن البيكتشرز فين؟
Pictures, view pictures, but it takes some time for loading.
Yes. It will load some pictures here. Just wait a second. ده في picture. Yeah. You see, to demonstrate your
Exercise.
yeah.
Okay.
So you can, if you don't want to read this, you can. This will be very useful for you.
Sure.
So you will just take exercise for today. Say how many minutes have you taken? Let's say for 15 minutes. Add to my diary. Okay, this tells you that the rank of this exercise will be updated. We rank exercises as well as food items, so you can find your most likely exercises first. And here, by going to the exercise diary for today, you'll find your which one?
I think it's I don't know. Which one would you take?
I don't know.
I can't remember. I think this one. I don't know. I can't recall. So I took some exercises before I calm down.
We tried it, sure. So that's the majority of it. Yeah.
Excellent. Now,
Okay.
why did you choose to do this particular project?
Sorry?
Why did you choose this to do this idea?
Okay, lots of people imagine a great body and a great healthy life. So the health is not a relation between the doctor and the patient. The health is you, is your eating, is your exercises, is your quit smoking, is your lifestyle modifications. So we thought about this idea, and we think it's an innovative idea and a new idea. It's not an only idea; it's a vision for the future. That's
what we mean is you don't have to be sick in order to watch your health. So you can watch it even if you're having a great body, or even if you're a little overweight or underweight. It can give you a diet plan to maintain your current status, your current weight. So it's kind of flexible. It's kind of fun. Yeah.
Very good.
Okay.
Well, it was great meeting you guys, and good luck to you.
Thank you.
Thank you.
All right, now we're with Team Austria. So, how are you guys doing?
Fine, thanks.
Yeah, who are you?
I'm Kang Lee, and I'm studying business and computer science at the Vienna University of Technology. And
I'm Alex. I'm from both universities listed here. I do informatics, computer science on one side and economics on the other side. And our project is called CAPS. Basically what we do is we try to provide a framework for game developers to implement context-aware games, as we call them. So what we do is, context in our case is positioning. Where are the players during gameplay? And this is quite interesting in a health aspect and health context because you can get people to move around during gameplay, which is what we would like to motivate people to use. Instead of thinking, oh, I need to do sports, think I'm going to play a game. And during the game, oh, I have to run around and things like that. And basically, we've created a framework for other people, for game developers to do that, and we've implemented some prototype games. In one of our games, I'll show you a quick demo of it. It's called Hit and Run. Now, I'll just start the server here on this side. And it's played on mobile devices, such as this QTech smartphone. Now, it's going to get a bit hard. So, we're just going to start this. Now, Kang has got the other device in his hand. And you can see the logo here, running, Hit and Run. And Kang and I are now going to log into the server. And upload a photograph. So, we'll get you on the photograph in a moment. So, now let's photograph our Australian neighbours. So, we have the kangaroo, and there you can see the photographs on the server on one side. Now, I'm playing Mary, but I'm Alex, of course, but still playing it. Now, you can see already here, while we're waiting for the photograph, got to press the button to arrive. The game of the game is to collect points. Now you do this by, if we wait a moment, just waiting for the server to initialize, and you can see these fields. Now the game of the game is that you hit the blue points. Hitting the blue points gives you points. Now in this case, I accidentally pressed a red button. As you can see here, these things change, so you might actually hit a red button. Now the game of the game is when you hit a red button, you have to run away from the wireless access point as far as you can go before the game tells you to run back. Now, the more you run, of course, the more your concentration lacks, and the more you hit the wrong buttons, because they're changing all the time. If you press a blue button, you just accidentally hit the red button. Now, why are we doing this with the wireless? Basically, our positioning system usually is GPS. But, as you can see, we're inside, and we don't have indoor GPS. So that's why we're using a more inaccurate wireless LAN system, just to give you an indoor experience as well.
Sure.
But usually we play these games outside. And the other games, we have some other games implemented as well, just to give you an example of a bit of a different type of game. We can't actually play this because we're on GPS inside, but just to explain how it works. We don't want to just target young people that like these fast-paced games. We want to target the whole range of people, adults, elderly people, for example. And we've implemented what is called City Hunt. In City Hunt, it's a game that you play in a real city, in a big city, and you collect photographs. Now, you get a set of questions where there are points of interest listed. So, for example, in Vienna, you can visit the Stephansdom, which is a very interesting point of interest. It's a great cathedral, and you're asked to take a photograph of it. And you walk around the whole city all day if you have enough questions, and compete against others in the time that in the time that it takes to collect these photographs, for example. And there's a community where people can then sort of compare their high scores, compare their photographs even against each other. And this is the exact opposite of this fast-paced game. It's a very slow-paced game, basically.
Interesting. So let me ask, why did you choose to do this for the event? Why did you choose to do this specific game for this event? Let's talk about the implications for health.
Yeah. Basically, the competition theme is technology helps us live a healthier life. Now, what is health? Health can be very broadly interpreted. Now, we thought health is get people moving. That's CAPS. CAPS, get moving. That's our slogan. Now, what if we're looking at our youth? Lots of people, a lot of children sit in front of the computer and they're playing computer games. Why do they like computer games? Because they have these virtual elements in them. And we thought, well, these virtual elements, we can take them into the real world and make them sort of distract them from the act of moving, the act of doing sports, but still have their virtual elements. So our impact is basically people move while playing the game, and so they have a much more healthy life. They get back to playing around in a field like they did before there were computers, just they still have the virtual techie aspect, the gadget aspect in the game. Yeah.
And it works, you guys using web services?
we're using, if we go over to the architecture diagram, we can give you a quick. So basically, we're using XML web services at the bottom here for what we call pre-game communication. That means game retrieval, joining games, and things like that. But during the game, because we're using mobile devices, we have to serialize very fast, and we send a lot of messages back and forth. So we can't depend on the performance of the serialization on the mobile devices. So we actually implemented TCP sockets in the framework. So the game developer doesn't care about that. We provide the transport and the serialization, but the game developer only implements high-level messaging objects. So they have objects, and we take care of the rest, transport back and forth. So it doesn't really matter for the game developer, but we have to use faster sockets just to be able to provide fast communication.
So now these are managed objects?
These are managed objects. The complete framework is in .NET, and basically these managed objects are serialized down to the, in this case, TCP socket byte level, so they're serialized to byte arrays, so we can transport them back and forth.
Excellent.
Yeah.
Very cool.
Thanks.
How about asynchronous?
Asynchronous, well, we don't really have asynchronous. We have offline-online capability because, of course, when playing, for example, City, you're in a city, you don't have the wireless connection all the time, especially not in Vienna. But so the clients are actually offline capable. They just switch off, and as soon as you're in range again, it connects to the server if it can find it, and then continues playing. So we don't have asynchronous in that sense, but it has offline capability.
It's limited to 2 people playing the game.
No. We only have 2 mobile devices here. That's why we're playing with 2.
Excellent.
Basically, exactly. Hit and run is actually, you can use any number of people. The server, the most we've played with is 3 because we only had 3 mobile devices. But basically, we could, if we had more devices, we would play with more players.
Cool. Excellent. So now, why did you join the Imagine Cup? What is it about it that got you guys excited about it?
Well, I've been taking part in the Imagine Cup since day 1, since the first year. The first 2 or 3 years, I think the first 3 years I competed for Germany, and then I moved to Austria and started competing here. I was in Yokohama last year, and it was just amazing to see all these projects, and it was a motivation the first time because I wanted to do something, do a project. But as soon as you're at one of these world finals, you have so much motivation for next year because you see so interesting ideas, you see how people have implemented, you see what they've been able to do, and you're just so inspired. And the theme changes constantly every year, so you get the motivation to think about new projects and new ideas. So that's basically why we're here again, even though it's a lot of hard work, but it's worth all of it. This week in India, I mean, we've only been here 3 to 4 days already, but it's great, so it's worth every hour we've invested in it.
Well, great to meet you guys.
Thank you.
I'm kind of quiet over there, but understood.
Right.
All right. Well, hey,
Right.
good luck to you guys.
Thank you.
Nice
Thanks.
to meet you.
Right.
All right. Team Canada.
Okay.
How are you guys doing?
Good.
So what's going on here? Who are you?
Okay, well, my name is Andrew Dionrain, and I'm a third-year medical student at the University of Toronto. And this is Rishi Gupta. So he just graduated from the MD program at the University of Toronto as well. And here at the Imagine Cup, we developed a clinical translation system. So how it works is when you have to work with a patient who can't speak English, what you basically do is you speak into the computer, and the computer will translate the phrase into something that the patient can understand in their own language. And in addition to playing back audio and translations and things like that, it also displays video, pictures, tables, charts to the patient, so the patient can get the idea of what you're trying to ask them. And then they can communicate back by pointing, gestures, and using things like that. Yeah.
So it's an automatic translation system?
Absolutely, yeah.
How many languages do you cover?
So right now we cover 12 languages, but we're looking, it can be expandable to as many languages as you want. And the nice thing is we're working on developing a PDA system, so a handheld system. So the idea is that you can take the technology out if you worked with Doctors Without Borders to a remote country. You can do the translation on the fly there. You don't have to be hooked up to any big organizations or computer networks or anything like that, and you can take it with you wherever you want. So
what led you to create this application?
Well, I guess we're from the University of Toronto, so Toronto is such a multicultural city. We're always dealing with patients who come in, and you've got to deal with patients in Spanish and Tamil, all sorts of different languages. So Andrew and I got to sort of talking about that side of things, and we thought it'd be wonderful if we could develop some sort of thing to allow health professionals to talk to their patients and actually be able to communicate in situations when that was difficult. I think we all know how frustrating it can be to not be able to communicate with other people, and when it's your health, it's all the more important. So that's sort of where it came from. So why don't we bring you over here?
Sure.
So we'll show you what the program does here. So why don't we just get it up and running?
Doctors who write code, I love it.
Yeah. So it's a very simple to use type of interface. And for example, what you do is in Canada, one of the official languages is French. So we're going to pick French here. What you do then after picking French is you pick your voice gender. So if you want to speak with a male voice, that's fine. If you want to speak with a female voice, you just select it there. And then you change the patient gender as well, because the phrases change based on that. And then what you can do is basically you pick your phrase, if you like, just from the menu. So you can go, do you have any chest pain? And then, so the computer will play it out. And in addition to just playing audio, so if we go down here, so I'm going to pick, please walk toward me. And what we can do is, let me just go up. So then in this case, it'll play a video, and then it plays a translation. So in addition to getting just the audio output, you can get videos and charts and tables working as well. And you can also speak into the computer. So the idea is that, let me just get the microphone over here. Now, it's a bit noisy in here, so we're going to have to see if this works properly. Normally you want to do it in a quiet room, but do you use crack? Crack. So hang on. Don't want to think of that.
That would be an interesting one to translate.
Do you use drugs? Drugs. Yeah, see, it's too noisy in here. Please stand up. So, yeah, so basically, even though there are all these errors in it because of all the background noise, it can still filter out a lot of the errors. And the idea is that, you know, you can talk to a patient naturally. You don't have to use any of the exact phrases that occur in the database. And it uses a thesaurus matching system, and it also lines up all the principal words in the sentence, so that it's almost like speaking to a translator. So the previous example, we can say, do you use crack, do you use speed, or do you use heroin? And then the computer will ask the patient, do you use street drugs? So it will make a doctor's speech very polite, very formal, even if the doctor isn't speaking like that. So that facilitates communication with the patient as well. So
what translation service did you hook into? Using the Windows translation APIs?
So what we ended up doing was we used Microsoft voice recognition, and then to do the actual translation, we worked with a clinic in Toronto called Access Alliance. And they're a multicultural health clinic, and we compiled a list of commonly used phrases, and we got it translated into Polish, Portuguese, Ukrainian, Russian, Chinese, a bunch of Indian languages as well. And we put them on the computer, and then we used the Microsoft voice recognition for verbal input, and then to match it to the pre-translated phrases, we developed an algorithm called the semi-search algorithm, and that finds the best matching pre-translated phrase based on the meaning of the sentence. We actually have a patent pending on that algorithm, because it can actually be used as a search engine as well to search based on meaning rather than exact phrase matching. So, yeah.
I'll show you just one other thing as well. This is a prototype here of what could be a portable version, sort of a PDA of the translation tool, and that would allow people, as Andrew was saying earlier on, if you're working with Doctors Without Borders or something like that, doing volunteer work in an area where you feel your language skills aren't up to par with the local languages, then you can use this translation tool and you'll be able to go in the field and work there.
That's excellent. Really excellent. Well, good job.
Great.
Thank you very much.
Nice to meet you guys. Good luck
Nice to
to
meet
you.
you. Thank you.
Thanks.
All right, we're with Team Colombia.
Yeah, we're from Colombia. Well, now we're going to do my project. It's EAV Mobile Diagnostic. It's our team. We're from. This is Jorge Iván Giraldo. My name is Roberto Erazo. He is Jorge Galíndez. He is Carlos Cobos, our mentor. This is Jesus Muñoz, our partner team. Well, now our application and our solution contains our one measurement device that perform a diagnostic of the person and indicates and give to the person some advices of the healthier lives. How can the person have a healthier life based in a full diagnosis of all the organs of the body, applying a method that are called electroacupuncture according to fall. Yeah, this is a German method that's apply acupuncture Chinese, traditional acupuncture Chinese, with a modern electronic, and it's only a method that we wanna populate to the world to use in all the homes in all. To any people, because the people don't know, doesn't need have a knowledge base in acupuncture or in electroacupuncture according to fall. The application is so intuitive and easy to use. And if you like to see what helps, okay, come on here, please. Well, first. Then we have our measurement device. Okay. Here, you know, it's so big electronic target, but this can be reduced to more products. Okay. We only here applies with here. You have to hold this in one hand and then put one and applies with another electrode with this in the other hand, in some points in the hand, that the application shows you how you can take the measurement and go step by step in each point of your body that control a specific organ of your body, you know. Now the most interesting of this application is the simple and it's so easy to use, you know. Okay. By other side, we have a web application that allows to the research, investigation, governments have a tendencies of the measurements in by continent, by country, by state, even. Have an average of the measurements of all the people that use our system to get health plans to prevent. Our mission is prevention. The prevention is the key for healthier lives. If we have and if the people use our device, we assure that the people can prevent the diseases. Okay. And another application, it's Jorge. Oh, okay. Our Pocket PC application that
so you can
allows
do this all remotely.
Yeah, you can go to the doctor with your Pocket PC and shows the last measurements that you are making. And this is a recommendation. This method not replace the traditional medicine. Even some recommendations are saying, please go to the doctor now, because our system is a diagnostic system. Yeah, it's not a treatment. It's not it's not for
Diagnosis?
well, it's only a diagnosis, you know. It's an energetic because it's based in acupuncture, in Chinese acupuncture. It's not a clinical state of your body. Maybe if you take a measurement now, and maybe your heart is bad in our system, maybe if you go to the doctor, the clinical information is, oh, your heart is okay. But energetical and the energy of your body indicates that maybe your heart can be false in a moment. Okay. Now this is the prevention because it's comprobated in the time that the energetical signals appears first than the clinical problems. Okay. And this is the most interesting of our system. This is a system that combines modern electronic, homeopathic medicine and allopathic medicine because even in some recommendations we say to the patient, please go to the doctor, or please eat more fruit. Our advices it's an advices that the people can understand. It's not an inflammation. It's not hey, you have inflammation in your, I don't know, in your pericardium or something like that. Okay. And if you want to see, this is our web application. You have here. Well, I have to log in. J. Galindez, okay, and here J. Galindez, and here you have to log in. Only the administrators can see this medical information. Yeah. For the rest of the world, you can see more information about electroacupuncture, but it's not available to other. Well, here you have a list of continents. Well, for example, go to South America. Go to Colombia, or maybe go to in Colombia, for example. Here appears in a graph chart. This is the tendencies in South America, and this is the tendencies of Colombia. All of these are electroacupuncture points that indicate how it's the functionality of a specific organ. Yeah, and this indicates that in average in Colombia the people, maybe for example, it's not so cool here, but if you have the chart, the bar chart, maybe you can see better. For example, this point, right,
what?
This RSIS, what? Right skin. Okay, well, you know what? Maybe this is the lung, or this is the intestine. For example, in Colombia, the tendencies it's in 41. That implies that it's normally, but can be in degree, in a degeneration of this, but it's energetical way. Okay, if you have more information, for example, from Colombia here, you have to select, and this display the states of Colombia, and you can do a more specific analysis of tendencies. For example, in Cauca, here we have different data because are many people in Colombia that are another sons of this country. Okay. And this is the most important thing of the web application. When you access to our desktop application, the most important here is the most important part of our application. This is how the people can take a measurement, and this indicates point by point how the people can take this measurement. This, for example, is the last measurement that the patient are making, and now we're going to make another measurement, for example, and and here indicates this green area indicates the normality of function of this point of this area. Above of that, it's inflammation, and below of this area, it's degeneration. Yeah.
Okay.
If you can see, for example, some measurements that this patient is making. For example, these have right small intestine test or circulation test. For example, go to here and go to the last measurement, and here appear the 3 points that are related with the circulation, for example, and this is the recommendation. For example, go to the doctor, eat foods, preferably raw, do gymnastics, exercise, avoid the blows. Yeah? You know, this recommendation is so easy to understand from the patient, and is a healthier lives recommendation. This is the most important, that the people know how to use this application. You know?
Very good.
Okay.
Well, good luck to you guys.
Thank you.
Nice to meet you.
Thank you. Thank you.
All right, we're here with some members of Team Belgium.
We are doing an advertisement and information interactive kiosk. It's a kiosk which gives information about environmental quality information. Here, air quality, so ozone concentration and such things. It can help people who have breathing problems. It can help them to be informed. Is the first step to be in good health. And this kiosk can give other information such as local healthcare center information. We can have a list of the local healthcare centers. We can have a map to go to the local healthcare center, make an appointment directly through the kiosk using an electronic identity card. We have electronic identity card in Belgium. And we can have weather forecasts. Weather forecast can give UV radiation and so on, and an interactive advertisement which enable passers-by to play with an advertisement and to get some vouchers or some maps to the nearby shops.
Excellent. So clearly, you chose this type of application because of the amount of bicycling that goes on in Belgium? So you chose this application because a lot of people bike in Belgium, yes?
This project here, the D-Bar, is was created by a Belgian inventor, and we make an advertisement for this project because it helps the health.
Very cool. So how does it work?
Sorry?
How does it work?
How does it work? It works through Bluetooth. So we use, thanks to a Bluetooth-equipped smartphone, we can connect to the kiosk and interact with this kiosk. Bluetooth, DirectX, and
nice. So you're controlling it right now with your phone.
Yeah, we can do. Montre peut-être les adresses. Adresses? Ouais, it's the local healthcare center module. We are going to browse to local healthcare center categories. Okay, we have, and now we're going to have information about this healthcare center, and we can get a map to go to this local healthcare center, for example. It's coming. Un peu à droite.
Oh, what's that? Very cool. Very cool. Well, good job, you guys. Good luck to you in the competition. All right, we're with Team Brazil. So how are you guys doing?
Great, actually. Apart from not sleeping, that's all.
Uh-oh.
It wasn't me.
That's cool. This is great. This has happened a little bit here.
Yes, quite a lot actually.
Cool. So we'll just focus in on this then while we're. So what did you guys make?
Our system works like a map for blind people. We have developed a couple of wristbands that vibrate to give directions for visually impaired people. So the user says where he wants to go, and the system identifies his position, the position of the places that he wants to go to, and traces a route. And that route is informed to the route via the vibrating wristbands that will, in real time, be guiding him, like saying forward, right, left, in a way that doesn't interfere with his hearing, because it's only in the wrists. So instead of actually hearing forward, right or left, he'd be feeling on his wrists the vibrating wristbands.
Excellent. So it's a guidance system for blind people.
Yes, it's a guidance system, and it can do lots more than this. It can be used to identify objects. So if the user is shopping, how does a blind user make a difference between 2 bottles of water? It could have Braille tags on it, but since most of them don't, and Braille is also hard to read on rounded surfaces, he could use our system to identify. He just reach for the object and say, identify, what is this? And then the system would say, oh, this is a bottle of water of a specific brand that costs $1, and things like that.
Very cool.
Yeah.
So how does it work?
Well, basically, it can work in both indoor and outdoor environments. The user must have a mobile device with them, or a pocket PC, a cell phone. So the user reaches for his cell phone and says where he wants to go. Take me to Taj Mahal, for example. And then our system will determine his position, determine Taj Mahal's position, trace the route. If the user is outdoor, all that's needed to determine his position is GPS, and for determining Taj Mahal's position is Microsoft Map Point Web Service. If the user is indoor, the system must be prepped, so there must be some kind of locating system inside the indoor environment. The one that we propose is one system based in RFID tags spread all over the place, and an antenna on his cane. So when he's walking by, the cane identifies, the cane can tell where he is. And the environment must be mapped so as to know if he wants to go to a bathroom, so we know where the bathroom is. And then he says where he wants to go, and we take him there.
Excellent. So why did you choose to do this particular project?
Actually, our idea shifted towards visually impaired people when my grandfather started to go blind. He started losing his eyesight a while ago, and then we started thinking, what could we do to help him? And after a long while thinking about it, we thought of the vibrating wristbands, and we thought, okay, this looks good, but how do we know it's good for real? So we tried to test it with real users. We've been able to work together with 3 different organizations for visually impaired people, where we had the help and the comprehension of lots of different people for testing our project, validating our ideas, and really understanding what our problem is.
So how did you enjoy the time at the Imagine Cup in India?
Amazing. I mean, every step you take is a new surprise. You see lots of very interesting projects, amazing projects, and you get in touch with so many different cultures. It's overwhelmingly incredible.
Excellent. Very cool. These guys, who are these guys?
This is Madison Costa, and this is Carlos Rodriguez.
How are you doing?
We are Team Brazil.
Team Brazil. Excellent, man. So where are you guys from in Brazil?
Recife. It's northeast Brazil. Yeah.
Interesting. Very nice. I know where it is. I've been there.
Oh, you've been there? Cool.
Yeah.
How do you like it?
I liked it. I used to live Boa Viagem.
Oh, you used to live there?
Yeah. My father was he ran the consulate, the American consulate.
Oh, cool. I thought you've been there, but I didn't realize you lived there.
I lived there. I went to American School of Recife.
Oh, cool.
For 1 year. Small world.
Very small world, indeed.
Well, excellent. So you guys had a good experience here.
Yeah, it's great to be here. I was here in the Imagine Cup finals in Japan last year, and this there, not here. It's so close to and it's just a new experience, and see a lot of people who are looking for solving problems with health. Is interesting, using different technologies, different language, different everything. Is a new and big experience for us. It's very exciting, very exciting.
My story. Well,
very nice guy.
yeah. Well, I'm the hardware guy of the team. Yeah. So, whoa, that was going off again. So I think it's a good time to show the wristbands by this time. So, in here we have. Ivan, can you hold it, please? Sure. So basically this is VI, our pair of wristbands. So you have here two Bluetooth modules which are used to communicate wirelessly with a pocket PC or a smartphone, as Ivan said. And here you have also RFID technology in order to help you to identify, this is the antenna, to help you to identify items. And well, the main character in these wristbands are these motors that make the vibration. I think that's it about the hardware thing.
Cool. Now, have you noticed that it helped your grandfather find his way around?
Unfortunately, my grandfather can't use the system because he's also got Alzheimer's disease, so he'd be unable to understand how to operate it. But we've been able, as I said, to test it with visually impaired people, other visually impaired people on the organization that we've worked with. So we've been testing, and we're still testing all the time and validating our features and everything.
Perfect. Well, great job, you guys.
Okay, thank you. Thank you.
It's a great invention.
Okay.
Good luck.
Bye bye.
See you very much.
Ciao. Ciao.